Hello, National Fives. The topic we're doing today is on arcs and sectors. Now, an arc, as hopefully you can see from the diagram, is part of the circumference of a circle. So the circumference of a circle is all the way around the perimeter of the circle, but an arc is just a fraction of this. Now, if you draw two radii, or a radius here and a radius there, they're bounded by an arc. This makes something called a sector, which you can see is shaded in. Now, what we're going to do today is we're going to learn how to work out the length of an arc. Now, as you can see in the example, we are given the angle at the centre and we are given the radius of the circle, and we're going to try and work out the length of this part of the circumference, which we call the arc AB. Now, you should already know from previous years that to work out the full circumference of the circle, the formula is C equals pi d. So if I was to do this, C equals pi d, I would just do 3.14 times 20. Now the diameter is 20 because the radius is 10 and the diameter right the way across is double 10, which is 20. So if you do that on your calculator, you will get 62.8 centimetres. Now, how do we then get this fraction of the circumference? Well, a full circle or a full turn is 360 degrees. So what fraction is this arc? It's 60 out of 360. So that is the calculation that we do. So the length of the arc is 60 out of 360 of 62.8. Now, if you're not sure how to do this, you could simplify it and do it without a calculator, but we have the benefit, you would have a calculator for this just now. All you would do is 60 over 3, so that means 60 divided by 360 times 62.8, and you should get the answer 10.47. This is another example which is very similar, and again we're given the angle at the centre and we're given the radius. So again, if we were going to work out the full circumference all the way around, whole from start at C, go all the way around, you would use that formula, which we've learned before. So, same as example 1, C equals pi d, so it would be 3.14 times 40, remembering again to double the radius to get the diameter. So the circumference would be 125.6. But that's the full circumference. We want just a fraction of the circumference, the arc length. Now, just to mention, there's obviously two arcs, because you could go from C to D anti-clockwise, and you could go clockwise. Now, the smaller of the arcs is called the minor arc, and the larger one is called the major arc. This might come up later on. So, again, we multiply by the fraction, so it's 150 out of 360 of 125, or this time I've written times 125.6. So if you do 150 divided by 360 multiplied by 125.6, you should get the answer 52.3. Now, the process I used for examples 1 and 2 is not the most efficient. It's quite long, but I showed you that on purpose so you had more understanding. Now, in reality, what I would like you to do is, if you could just remember that the arc length is the sector angle, the angle at the centre, divided by 360 times by pi d. It's the fraction times the circumference. And I would write this, or I hope you would write this, in shorthand like this. So L means length of the arc equals angle over 360 pi d. Alright, and now I'm going to do two examples using this more efficient method. So, example 3. Working out, very similar to example 1 and 2, but we're going to do it with the more efficient method. We're given the radius is 5 and we're given the angle at the centre. So, this is a three-stage process. You write the formula, L equals angle over 360 pi d. We then substitute in the numbers we know, because we know the angle is 100 and the diameter is going to be double 5, which is 10. So it'll be L equals 100 over 360 times 3.14 times 10. Now in your calculator, you would type that in as 100 divided by 360 multiplied by 3.14 multiplied by 10. And you should get the answer 8.72. Example 3 is very similar. It's just you've not got the full circle drawn. But because it says calculate the arc length, you can assume that it's a sector of a circle. It probably would in a normal question say this is a sector of a circle. But because it says arc length, we can assume it's a sector. Now again, using a more efficient method to work out the arc length, we're just going to write this formula, which would be good if you could memorise this. So L equals x over 360 pi d. Now my angle is 140 this time, and my diameter is going to be 12 because it's double 6. So L equals 140 divided by 360 multiplied by 3.14 multiplied by 12, and you should get 14.65 centimetres in your calculator. Now, if you follow the instructions in the sheet I've emailed you out, you will now have a few questions to do on that. But I'm going to continue the video and show you the next part that follows on from this. Now, this is calculating the sector angle when the arc length is known. Now, this is a much more difficult type of question because you have to work backwards and you have to use a lot of algebra. Now, I'm going to let you see this example here. So, this time, as you can see, we have a circle and then we have the sector. But this time, we're given the arc length. Usually we calculate that, but we don't have the angle at the centre. So it's a different type of question. We still have the radius, so we'll be able to work out the diameter from here. So I'm going to show you how to do this. This is quite a complicated question. Now, how you would go about tackling this question is, now I've left the diagram there so you can see it. So you would write the formula, L equals angle over 360 pi d. You would substitute in the numbers. So L is 8.56 because that's the length of the arc. We don't know x, so just leave it as x. Pi is 3.14, or you can use the pi button in your calculator, multiplied by 20 because I've doubled the radius. Now, that's all quite simple. This is where it gets a little bit more difficult. This is where we have to use our equation rules or change the subject, but we have to rearrange it, the equation, to find x. Now there's loads of ways you could do this. The easiest way I think would be, because 3.14 and 20 are multiplying there, we can move them over to the other side. So they become divide when they move over. Now you'll notice that I've put it in a bracket because you've got to be careful here, because it's 8.56 multiplied by all of this. If you just typed in your calculator 8.56 divided by 3.4 times 120, it would give the wrong answer. So either use your fraction button in your calculator or type in 8.56 divided by bracket 3.14 times 20. So hopefully you can get that in your calculator, 0.1363. It will be longer than that, but I've rounded it to 4 decimal places. Still not finished there. We know x divided by 360 is this number. We want to find the angle. So what we do is the 360, you can either think of you're multiplying both sides by 360, or the 360 is divide and it moves over and it becomes multiply. Either way, angle x will be 0.1363 times 360, and that should work out. Your angle is 49.1 degrees. You now have some questions on your worksheet like this example. Good luck.